Hello, I'm Dr. Hulle. In this case, we will try to solve this problem. The statement is, for the circuit shown below, switch is in position 1 for a long time. The switch is shifted to the position 2 at t is equal to 0. Find the following. First point is, expression for voltage Vc of t for t greater than 0. We will draw the variation of Vc of t for t greater than 0. And finally, we will calculate current flowing through the capacitor and voltage across. To begin with, the first point, which is the expression for the voltage across capacitor, which is Vc of t for t greater than 0. Before that, we have to analyze the circuit into the two parts. That is, behavior of the circuit before switching and behavior of the circuit after switching. To begin with, the first point, which is the behavior of the circuit for t less than 0, which is before switching. Now, this is the original circuit. In this case, initially the switch is in the position number 1, that is in this position. Voltage V is connected and the steady state was reached. The steady state was reached, it means this capacitor is acting as the open circuit in the steady state. And whenever this capacitor is acting as an open circuit in the steady state, in that case, the voltage available across the open circuit or across the capacitor is same as the applied voltage, which is the 40. That's why Vc of 0 minus is equal to Vc of 0 plus, which is equal to the 40 volt. This is the behavior of the circuit before switching. Now, when the switch is shifted in the position number 2, that is whenever the switch is shifted in this position 2, this will be the part of the circuit which is I have shown here. In that case, the voltage, applied voltage is the 150 volt, the 40 ohm is the resistance and 2 millifarad is the capacitance of the capacitor, and we want to find out the voltage across the capacitor. This is the source driven RC series circuit with initial condition, because we have the initial condition here which is 40 volt and this circuit is the source driven. We will try to find out each point one by one. The first point, we are interested in the calculation of the expression for voltage Vc of t for t greater than 0. As already we have discussed, the voltage across capacitor for source driven RC series circuit with initial condition is given by the expression, that is Vc of t is equal to V minus, in bracket, V minus V0 into e raised power of minus t by tau. In this case, this V is the applied voltage which is 150 and V0 is the voltage before switching, which is the 40 volt. That's why in this case the V is 150 volt and V0 is 40 volt. And in this case we are also interested in the calculation of this tau, which is RC, which is 40 into 2 into 10 is power minus 3, which is 80 into 10 is power minus 3 second is the time constant of the circuit. Now, when we will do the substitutions, this V is replaced by this 150 and this again V is replaced by the 150, this V0 is replaced by the 40, because this V0 is voltage before switching and this time constant, that is tau, is nothing but 80 millisecond, that is 80 into 10 is power minus 3 second. And if we will simplify this circuit, in that case this is 150 minus this 40 will be 110, means it is 150 minus 110 into e raised power of minus t by tau is the expression. And finally Vc of t is equal to 150 minus 110 into e raised power of minus t by tau. Now look at this expression carefully. In this case, if we are putting initially the t is equal to 0 and if we are finding its value, and finally if we are putting t is equal to infinity and if we are finding its value, then how will be the case? When t is 0, e raised power of 0 is 1 into 110 is minus 110 and 150 minus 110 will be the 40, right? This is value of the voltage across the capacitor at t is equal to 0. And whenever we are putting t is equal to infinity, which is e raised power of minus infinity, which is 0, 0 into this value will be the 0, and this 150 means at t is equal to infinity, the voltage available across the capacitor is 150. Now look at, voltage before switching is 40 volt and voltage after switching is, in this case, it is 150 volt. Means obviously the charging of the capacitor takes place. Means voltage will charge across the capacitor from the 40 volt to 150 volt, which is maximum, which is at t is equal to infinity. That's why we have this case. In this case, V is greater than V0. V is the applied voltage, which is 150, and V0 is voltage before switching, which is nothing but the 40. So the resultant equation is similar to the charging of the capacitor, that is similar to the source driven RC series circuit. Only difference is that in place of charging its voltage from the 0 volt, voltage will start charging from the 40 towards its maximum value, which is the 150. Similarly, if we are trying to draw its variation, whatever I have discussed, I will put the same thing. Vc of t is given by expression 150 minus 110 into e raised power of minus t by tau. Calculating Vc of t at t is equal to 0 and t is equal to infinity. If we are finding its value at t is equal to 0, Vc of t will become, that is 150 minus 110, which is nothing but the 40, that is at t is equal to 0. This term will become 1. 1 into this value is 150 minus 110 will be the 140. Similarly, if we are finding its value at infinity, that is t is equal to infinity, e raised power of minus infinity, which is nothing but 0. 0 into this value will be the 0, means 150 minus 0 is the 150, means at t is equal to infinity, the voltage across capacitor is 150. Means at t is equal to 0, its value is 40, at t is equal to infinity, its value is 150, means the voltage across capacitor will increase exponentially and reaches to its maximum value as the time progresses by this expression, and expression is nothing but Vc of t is equal to 150 minus 110 into e raised power of minus t by tau is that value. Finally, we are interested in the third point, which is nothing but the expression for current flowing through the capacitor. Now here general expression for, or general formula for the calculation of Ic of t is equal to C into d Vc of t upon dt. In this case, C is the capacitance, which is 2 into 10 to the power minus 3. D by dt of its Vc of t, which is nothing but 150 minus 110 into e raised power of minus t by tau. If we are differentiating this equation with respect to t, in that case Ic of t, this term is the constant, differentiation of this 150 is the constant term, is 0, then this 110 is a constant, then e raised power of minus t by tau, its derivation is minus 1 upon tau into e raised power of minus t by tau, this value. If we are simplifying this whole expression, this minus sign and this minus sign, that will become plus, means here this 2 into 10 raised power of minus 3 into 110 into 1 upon this 80 into 10 raised power of minus 3 into e raised power of minus t by tau, which is 10 into 10 raised power of minus 3. Means finally, if we are simplifying this complete expression, the Ic of t, that is current flowing through the capacitor, is 2.75 into e raised power of minus t by tau is that value. Finally, if we are finding the voltage developed across resistor, that is VR of t is equal to R into I of t, which is nothing but 40 into 2.75 into e raised power of minus t by tau. Finally, VR of t is equal to 110 into e raised power of minus t by tau is the expression. That's all about this video. Thank you for watching this video. That's all.